Good morning guys, welcome to Videos Online Academy tutorial. Thanks for watching our videos online. Please, if you are not yet subscribed, please do well to press the subscribe button and the notification bell in order to see all of our educative videos online. Please and please remember to share these videos with your friends, families, relatives and colleagues at school. Thank you and God bless you. Today we are going to be considering the Ijmbe chemistry and particularly the past questions in organic chemistry for Ijmbe students, that is the A-level student. And here is power 2021 under chemistry on organic organic chemistry. And here before us we have the first question saying draw the structure of pentan 2-on. We are asked to draw the structure of what? Pentan 2-on. Draw the structure of what? Pentan 2-on. Now when we are talking about pentan 2-on. Now the on here signify that the compound belongs to the family of what? Alkanone group. Alkanone what? Alkanone. That is the ketone what? The ketone what? The ketone group. The on there shows that what? The compound belongs to the what? To the family called alkanone, known as what? The ketone group. And the ketone group have a general formula of what? Of R functional group. What? That's the general formula with functional group of R C double bond O prime. R prime. Now we have what? The alkanone or ketone group has what? R bond C double bond O, then what? R prime. So this is what? This is the functional group for what? Alkanone, also known as what? Ketones. Where R and what? R prime. Where R and I prime are key what? Are key group. Where R and R prime are what? Are key groups. And this what? A key group can be the same or can be what? Can be different from one another. So now this is the functional group of alkanone. And how do we now draw the what? The structure of pentan 2-on. Now from the word pentan means what? 5. Pent means 5. So it means that the structure is going to have 5 what? Carbon. And the location of the functional group will be on what? Number 2 carbon. So let's draw it now. We have 5 carbon as a result of pentan. We have what? 5 carbon as a result of pentan. 1, 2, 3, 4, 5. So the functional group will be on carbon 2 because it is pentan what? 2-on. Then you can now fill the rest with what? Hydrogen. Fill the rest with hydrogen. This one must have 4 bonds. 1, 2, 3, 4. So this one is already having what? 4 bonds. So you don't need to add anything to it. Add what? 2 hydrogen to this to make it 4. Also 2 hydrogen. And the last one is what? Hydrogen. So this is the complete what? Structure of what? Of pentan 2-on. So in a condensed form, when you condense the structure, you're going to have CH3, CH2, CH2, C double bond O. Or you can put it on the top or you put it on the what? Below, whichever the case you want to. Just make sure that you put it there. C double bond O, CH what? CH3 in a condensed form. So these are functional. You can see these are functional. So CH3, CH2, CH2, C double bond O, CH3. So that's the what? That's the condensed form of writing it. Some can decide to write it as CH3, CH2 brackets 2, C double bond O, CH what? 3. You can also find it like this. So this is what? This is pentan 2-on. Now the second question says that you should what? Draw a positional isomers. The positional what? Isomers of pentan 2-on. When we are talking about isomers are compounds which have the same molecular formula but different structure. So what do we mean by what? Isomerism. The word isomerism comes from isomers. And isomerism is the phenomenon whereby compounds have the same what? Molecular formula but different what? Structural what? Formula. Now, isomerism can be broadly divided into two what? 2 groups. Isomerism can be broadly divided into 2 groups, which are what? Which are structural what? Structural isomerism. Structural isomerism and stereo what? Isomerism. Stereo isomerism. Stereo isomerism. So we have structural isomerism and stereo isomerism. Under the structural what? Isomerism, we have what? 4 types. It can be subdivided into 4 types as well. So under stereo what? Under structural isomerism, we have 4 types. The first one is what? chain or branched what? Isomerism. Chain or branch what? Isomerism. Chain of branch what? Isomerism. The second one here that we have here is what? Is the we have what? We have the positional or metamerism metamerism. We have the word position or metamerism. The next one that we have here is we have the functional what? The functional group isomerism. The functional group isomerism. And the last one here is tautomerism. The tautomerism isomerism. So these are the four major types of structural what? Isomerism. But when I'm talking about what? Stereoisomerism, we have to deal with what? The arrangement of what? Of the arrangement of the component of a molecule in space. So this one has to do with the arrangement of what? Individual what? Element in the molecule in space. So it has to do with what? Arrangement in space, which we have two types, which is the what? The optical what? Isomerism and the what? This optical isomerism has to do with mirror image. And the last one is what? Under this one is geometric what? Isomerism. Now geometrical isomerism can be subdivided into 6 and what? Trans what? Isomerism. It's also known as what? 6 trans what? Isomerism. 6 trans isomerism. 6 trans isomerism. So geometrical isomerism can be known as 6 trans what? Isomerism. So these are the types of what? Isomerism that we have, the classification of isomerism. But now we are asked to draw a positional what? Isomers of pentan 2O. Now, positional isomers of what? The first question under that one is what? The big positional what? Isomerism. Positional isomers of what? The positional isomers of what? Pentan 2O. We know that the pentan 2O is what? CH3, CH2, CH2, then C double bond O, CH what? 3. And we're asked to draw the what? The positional. Now, if we count from here now, we can have what? 1, we have 1, 2. The position of this what? Of this carbonyl is on number 2. If we place it on number 3, then we are, if you place the what? The position here, we are going to have what? 3. We are going to have 3 pentan 3 on. Pentan 3 on. Let's place it. Let's change the position here. The position, this one is 1 and 2 before. So let's change the position. Let's change the position. This is the position. The position is number what? Number 2. The position here is number 2. Okay, the marker is writing. The position here is what? Number what? 2. We can bring it to what? Number what? Number 3. You know this is number 1. Number 1, number 2, number 3, number 4, number what? 5. So this is pentan what? Pentan 2 on. Now, if that is pentan 2, we can change the position of this pentan 2 on to be on number what? On number 3. So if we change it, this one what? CH3, CH2, C double bond O, CH2, CH what? 3. Now let's see whether we have what? Look at this in position number 3 now. Let's count. This is 1, 2, then number what? 3. So this is now pentan what? This is now what? Pentan 3 what? On. This is pentan 3 on. This is pentan 3 on. So this is a positional what? Isomers of what? Of pentan 3 on, because you have moved the what? The position of what? Of the functional group from 2 to what? To 3. From 2 to 3. So that's that about that. Although this, we don't usually have this pentan 3 on, because we prefer to count it in such a way that we have numbers of 1, 2, 3. 1, 2, 3. So you have what? Pentan 3 what? So 1, 2, 3. 1, 2, 3. We still have what? We still have what? Both sides, when you count from the back or from the front, we still have what? Pentan 3 what? Oh, so that's the positional isomers of what? Positional isomers of pentan what? 2O. Now the chain isomers. The chain isomers. Number 2. The chain isomers. Number 2. The chain isomers. When I say the chain means what? Branch. The chain means what? Branch isomers of what? Of pentan 2 what? Pentan 2-O. The branch isomers of pentan 2-O. Now, for instance, now coming to this place now, we can cut the branch. Coming to this place, we can cut this what? This branch and put it here. You cut this branch, which is what? Which is what? Methyl, and put it underneath here. So when you cut it, what do we have? Following this one now, when you cut it now, we have what? C, 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 and then C. You have 4 C. Then you remove one this hydrogen here. You exchange this one with what? This. Exchange this. This one will come here, and this one will go here. So now let's exchange it now. Let's exchange it as we have done. This is going here. So now on carbon what? We are on carbon 2 now. We are going to have methyl. On carbon 2, we are going to have methyl. So and hydrogen is coming back here. So making that 1, 2, 3. So we are going to have 3 hydrogen here. 1. Then the hydrogen here has been, the methyl has been replaced with hydrogen here. We have what? This one also have 1 hydrogen left. This one, this way, okay. So the functional group is on number what? Number 2 now. Then we have CH what? CH3. Now look at this. We replace this what? CH3 with H, and CH3 now comes to this place. That's why the methyl now is on what? Carbon what? On carbon 3 if you count from the what? From the back. So this is what? This one will not be what? Because we are going to count this so that this functional group has the least numbering. So we have 1, 2. So this is 2, and this methyl here is number what? Number 3, then this is number 4. So the branch or chain isomers of what? Of pentan 2, we have the what? 3-methyl, 3-methyl, let's see, 3-methyl, 3-methyl, then 3-methyl. Now, how many? What's the parent name? 1, 2, 3, 4. Butan. Now, butan 2-O. Butan 2-O. Butan 2-O. So that's that about that. 3-methyl butan 2-O. 3-methyl butan 2-O. So that's one of the words. That's how you can write the chain or branch isomers of pentan what? Of pentan 2-O. Of pentan 2-O. So that's that about that one. Question number 1D says that. Question number 1D says that draw a functional isomers of pentan 2-O, not an alkana. So draw what? Draw the functional what? Isomers of pentan 2-O. Now, the functional isomers of what? Pentan 2-O. What do you mean by functional isomers? Functional isomers in such a way that the functional group of that isomers will change, but the molecular formula will still be intact. For instance, now the number of carbon will still be the same, and the number of hydrogen will still be the same as the what? The number of the new compound. So what do I mean by that? When I'm writing functional isomers, the functional group might change. It can be what? It can be ketone functional group before, and it comes to what? Hydroxy what? Functional group, or alkanol functional group. But the number of what? Of individual element must still be the same. So that's what we know as functional what? Isomers. In such a way that we have different functional group but the same molecular what? Compound, same molecular compound. So, and we know that pentan 2-O is CH3, CH2, CH2, C double bond O, CH3. This is what? Pentan what? You can see 1, 2. This is pentan 2-O. Pentan 2-O. Now, how do we write this in such a way that we change this what? Functional what? The functional group. Now, we are told and we are specifically instructed that we should not write the functional group isomers of what? Alkana for the pentan 2-O, because they said, the examiner said, you need any other what? Other functional isomer apart from what? Alkana. Apart from alkana. So now, assuming it is alkana, it is easily drawn, because we just have to change the position of this and bring what? Like this CH3, CH2, CH2, then this will be what? CH2, bring this one in, you bring CH2 in, then it remain one hydrogen and you put it in the front, CHO. So meaning that you have CH, CH2, CH2, C double bond O, then H. This is what? This is pentanal. But the question says this should not be given as one of the functional isomers of the what? Of the compound. So that's why we are not, this is not accepted. Not accepted by the what? Examiner. Not accepted by the examiner. So let's think of another what? By the examiner. So now let's think of another what? Compound. Another way that we can write what? The isomers of pentan 2O. We can't have to write what? The alkyl what? Group. No, now since we have double bond here, why can't we also introduce what? Double bond. Why can't we also introduce what? Double bond into this what? Into this compound. Now let's draw what? The what? Write the 5 what? Carbon first. Then let's introduce the double bond into this group. Now we introduce double bond to what? Carbon 2, because it cannot be in carbon 1 and it cannot be in what? Carbon. We must give it the least numbering of what? Of carbon. So since it cannot stay in carbon 1, we should introduce what? The double bond in carbon what? 2. So now the double bond is staying in carbon what? In carbon 2. Now since we have O oxygen, we can only have what? CO, or we can also have OH. We have hydrogen and O. So we are introducing OH as well to cover for what? Oxygen. We are introducing OH as well to cover for what? Oxygen. So with this now, let's try to fill the what? Fill in the what? Fill in the hydrogen. Now, so we have what? Hydrogen here, hydrogen here. We have now this one 1, 2, 3. It's only one hydrogen that we can put. So let's put also this one hydrogen. This one we have 2 hydrogen. This one 2 hydrogen. 3 hydrogen here. So let's see whether it has what? The number of carbon is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. That one is what? That one is what? Intact. Now let's count the number of hydrogen now. 1, 2, 3, 4. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's also as 10 as well. Look at this. Here is 10 hydrogen, 10 carbon. 10 hydrogen, 10 carbon. So meaning that this compound is an isomer of what? This. And we have 1 oxygen, 1 oxygen. So this is an isomers of pentan 2O. This is an isomers of pentan 2O. And how do you name this compound now? Given this the priority, the alkyl group will be given priority. This one will be 1, 2. So 3, 4, then 5. This is pentan. Now, because it's supposed to be pentanone because of this priority, but this you have double bond here, it's going to be what? Pentan 2 in no in. Now in plus O, it now be what? In O. Pentan 2 in O. So that is the functional group of what? The functional isomers of pentan 2O. Pentan 2 in no. So that's that about number 1 question. So let's go to question number 1. Now question number 2 says that identify the 3 pollutants produced during the combustion of alkanes and their sources. So identify the pollutant produced during the combustion of what? Alkanes and their sources. Now we are talking about combustion of alkanes. Combustion of what? Alkanes. Alkanes are hydrocarbon with general molecular formula of what? CnH2n plus what? 2. Now, incomplete combustion of what? Alkanes leads to what? Incomplete combustion of what? Alkanes leads to formation of CO. Now, we have combustion of what? Alkanes. That is, when I talk about combustion of what? Of alkanes, we are talking about what? Alkanes plus oxygen to give what? CO2 plus H2 what? O. But there are some what? Pollutants that are produced along this what? Along this product. For instance, now if there is incomplete combustion of what? of alkanes, definitely you are going to have what? You are going to have CO, carbon what? Carbon 2 mono what? Monoxide. Carbon 2 oxide. This is carbon monoxide. We are still going to have carbon black. Carbon black, that is in form of what? Co. Because we are going to have carbon black, that is carbon black, carbon in form of carbon black. Also, we can also have what? Nitrogen reacting with what? Oxygen. To have what? NO. To have NO from what? NO2. So, carbon 2 oxide can be formed as a result of incomplete combustion of what? Of C and what? O2. So CO can come as a result of what? As incomplete combustion, as a result of incomplete of what? Formation of CO2. And also NO can come from NO, NO2, and so on and so forth. So these are the what? These are the pollutants that can cause carbon black, CO, and what? NO from what? CO can be formed from incomplete what? Formation of CO2. Then this one can form as a result of what? Carbon that is not completely burned as well. And NO can come from what? Nitrogen in the what? In the atmosphere. So that's that about that. That 3 questions says, consider the what? The reaction scheme below. We have to consider the reaction scheme below. So the reaction scheme below here, this reaction scheme, we have to consider it and use it to answer the question. So now, if you look at this reaction scheme, you have to study it very well. This is what? This is 1, 2, 3, 4, and it's having functional group of what? Look at it, it's having functional group of what? Of C double bond O. This is what? A carbonyl what? Group, especially ketone. Why? Why is it ketone? Because we have what? It is ketone because this is. It is ketone because this is what? R, and this is R prime. This is methyl, and this is what? T. So this one is what? It's a ketone group, that is alkanone, and this alkanone is what? 1, 2, 3, 4. It is what? Butanone. It is butanone as a result of what? 4 what? 4 carbon and functional group of what? Of C double bond O. So this is butanone. Now undergoing reactions. Undergoing reaction 1 to form what? Look at this is a cyanide what? We call this one cyanide group. Cyanide. So cyanide is as a result of what? Of carbon and nitrogen. We call it cyanide. So now I will also have what? An hydroxy what? This is an hydroxy group from what? Hydroxy group. You have to know this hydroxy group. And this cyanide what? Group. So now, so that's the first reaction 1. That's the reaction 1. That's the what? Reaction 1. Now let me clear this for better understanding. So this is the hydroxy what? We have the what? So this one is cyanide group. This one is what? Hydroxy what? Hydroxy group OH. Now for the reaction 2, you can see that here we have alcohol group. As a result of this, we have alcohol group. This is an alcohol group because it has a functional group of OH. And which class of alcohol is this? It's having 1 hydrogen atom. This is what? This is what? Secondary alcohol, because it's having what? It's having 1 hydrogen atom. An alcohol that has only 1 hydrogen atom attached to the what? To the carbon atom, the alpha carbon atom that is carrying what? Alpha carbon atom is a carbon atom that is carrying what? The hydroxy group. So this is what? A secondary what? Alkanol. But we are not concerned about that. We just know that this is an alkanol. So, and it is what? Butanol. This is butanol. This is butanol. As a result of OH, butanol, and it has what? It has 4 carbon, 1, 2, 3, 4. So this is butanol. This is butanol. Now this butanol, on the presence of excess what? Concentrated hydrogen tetrasulfate 6, which is known as what? Tetrasulfate 6 acid. In the presence of what? In the presence of excess tetrasulfate 6 acid, under what? Under the temperature 180 degrees Celsius, it produces butene and but1 in and but2 in. This is supposed to be hydration what? Dehydration what? Reaction. This is dehydration what? Reaction. So it's what? It's a removal what? It's a reaction that involves removal of water from what? From butanol. And this also is what? This is a what? A reduction. This is an addition reaction. whereby cyanide is added to what? Butanol to form what? Cyanohydrin. We call this what? Cyanohydrin. It's called cyanohydrin. This is cyanohydrin. When you add what? Cyanide. When you add what? Hydrogen cyanide. In the present, when you add hydrogen cyanide, from that hydrogen cyanide is obtained from sodium cyanide. The hydrogen cyanide is obtained. I will still write the reaction. The hydrogen cyanide is obtained from sodium cyanide in the presence of what? Hydrochloric acid. When you add it to what? This, you are going to get cyanohydrin. And when you add water to cyanohydrin, you get carboxylic what? Carboxylic group. So now let's go into the what? Question first. Let's go into question. Just you need to get the reaction scheme because we need to consider the reaction scheme first. So now that's when the 5.0 now is what? When 5.0 gram of butanol was used to carry out the reaction 1. Reaction 1 is reaction 1. The yield was 64%. The yield was 64%. Theoretical what? Maximum. Calculate the mass of compound what? A. Don't forget this compound A. If 5.0 gram, now look at this butanol. Butanol now. I'm trying to solve the question here. So butanol undergo reaction 1. Reaction 1 to produce what? Don't forget, I told you that this whole compound there is called cyanohydrin. To give what? Cyanohydrin. They don't ask what to name it, but cyanohydrin, which is what? A. Cyanohydrin, which is what? A. Compound A. We are now told that what? 5.0 gram of butanol was used. The actual what? Mass used to produce this what? Reaction is what? 5.0 gram. The yield was theoretically what? Maximum. So the percentage yield, we call it what? The percentage what? Percentage what? The percentage yield or percent what? Yield. The way you want to call it, the percent yield is 64 what? Percent. You see what? Percentage yield at the end of the day theoretically is what? 40 what? 64%. Calculate the mass of compound what? A, which is cyanohydrin. Now how do you do it? The first thing is to what? Balance, or the first thing is to write the equation for the reaction which has been given to us and relate it was stoichiometry. And relate it was stoichiometrically. Relate the equation stoichiometrically. Now, how do you know about that? How do I do about that? That one is you go about it by what? Writing the reaction first and what? Because percentile yield, the percentile yield or the percent yield is given as what? Percent yield is given as what? Actual yield. Actual yield, percent yield is given as actual yield over what? Theoretical what? Yield times 100. Theoretical yield times what? 100. The percent yield is equal to actual yield over what? Theoretical yield times what? 100. So that's the percent what? Yield for you. And to get what? The mass of the compound formed, which is what? Mass of the actual what? Yield. To get the actual yield of what? Of A. Meaning that we are going to get the theoretical yield of what? Of A first, so that you can what? You can multiply with what? The percentage that they are given to get the what? Actual yield of what? A. And how do you get the theoretical what? Yield of A? You go back to the reaction. You go back to the reaction. You are told that the butanol, when you combine butanol and you write it in what? In a condensed form, you are going to have CH3, CO, CH2, CH3 now produce what? It undergoes reaction in the presence of what? Don't forget that the reaction here is addition reaction. In the presence of what? They add what? Addition reaction, they add what? Sodium cyanide. In the presence of what? Hydrochloric acid. So when this sodium cyanide and what? Hydrochloric acid combine, they form what? Hydrogen cyanide. The result will be hydrogen cyanide. So you can as well say that this compound is reacts with hydrogen cyanide to give what? To give what? Cyanohydrin, which is in the condensed form of CH3, CH, then what? CH2, CH3. Now you must write it in the condensed form so that you can calculate what? The molecular what? The molecular mass. So this one I can next count 1, 2, 3, 4. So 1, 2, 3, 4. So that's the what? That is the number of carbon that is here. 1, 2, 3, 4. So C4. How many H do we have here? H do we have here? That is H3, H5, H6, H6, H4, H6. Then we have one O. Let's count it again. We have C4, H3 now, H5, H8. Okay, this is what? H3, H5, H8. Then we have one oxygen now. To give what? The presence of what? Now I said this one will combine together to give what? Hydrogen what? Cyanide. So hydrogen cyanide will combine to give what? This one. The product will still what? CH what? Now combine this, how many carbon we have? 1, 2, 3, 4, 5. C5. 1, 2, 3, 4, 5. So that's C5. This one is what? H3, H4, H what? H6, then H9, H9. Then we have what? Carbon here. Carbon, then we have one carbon, one oxygen. Now let's find what? The molar mass, because we have to relate it stoichiometrically now. We have to get what? The actual, the theoretical value is obtained stoichiometrically. Theoretical value is obtained stoichiometrically, that is, from the stoichiometric reaction, from the balance reaction, we have to obtain it what? We can get our what? We can get our theoretical value. So now getting the molar mass of this now, we have what? 4 times what? 12 plus 8 into 8, bracket 8 multiplied by 1 plus what? 1 times 16, bracket close. Now let's find molar mass of this. So it's 5 times what? 12 plus, now 9 times 1, that is what? The atomic mass of hydrogen, plus 14 times 1 of what? That is what you write, that is 1, plus what? 16. So when you add everything together now, not make, this one is 48, this one is 8, this one is what? 16. And this one, the other side of this, we have what? 5 times 3, 60. 16 plus times 9, that is 9, plus 14 plus 16. So when you take your calculator, what do we have there? 48 plus 8 plus 16. This is 72 what? So 72 grams of this compound of C4H8O. We have to what? Now let's add this one together. Let's add it. 60 plus 9 plus what? 140 what? 114. We have 60 plus 9 plus what? 14 plus 16. We have with 99 grams. Okay, 72 grams of what? C4H8O. 72 grams of C4H8O. Now produce what? 99 grams of C5H9NO, which is what? Cyanide. So what about what? 50 gram now. So it's just a name, simple arithmetic. So now, so if this 72 produce what? This now. If 72 grams of this produce this now, what about what? 5 what? Gram of this. What about 5 grams of what? Of C4H8O. We give what? X gram. X gram. We give X gram. So we cross multiply. And we cross multiply. This one multiply by this. This one multiply by this. So we just get this value of what? Of this one produced theoretically now. The value of A produced, don't forget it is A. Theoretically is A. So now the value of what? Of A produced theoretically now will not be what? So the theoretical value of what? A. The theoretical what? The theoretical yield of A. Now by cross multiplying now, this one is 5 times what? you cross multiply. 5 times what? 5 gram here, multiply by 99, you cross multiply. So 5 times 99, then divided by 72, because so you have what? You have what? 5 times what? 99 over what? 72. So that is the theoretical yield of what? Of compound what? Of A. So now let's press the calculator. Now we have what? 5 times 99 bracket close divided by 72. So we have what? The answer here is what? 568.875 grams. So you can see that from the reaction now we are able to get the theoretical yield of what? Of A. That is the theoretical yield of A. Now we are given that the percentile yield. Note that the percentile yield of A is what? The percentile yield of A is 64%. So the percentile yield of A now is equal to what? Actual yield of A. Actual yield of A. Let me just average the actual yield of A and theoretical what? The theoretical what? Yield. Theoretical yield, the actual yield times what? Times 100. So 64% now. Since you have write 64 over 100 is 64% now, which is 64% is equal to what? Equal to what? What is actual heat? Actual heat is what we are what? We are looking to calculate the mass of compound of A obtained after the experiment. The actual heat obtained after the experiment over the theoretical heat that we want to obtain 6.875 multiplied by 100, when you divide both sides by 100, you have 64 over 100 equal to what? Actual heat over 66.875. So by cross multiplication, we have y actual heat equal to 100. You multiply 64 times what? 6.875 over what? Over 100. So actual heat is equal to what now? When you multiply this, multiply by 64. Okay, this one gives us 440 divided by what? 440 divided by 100 now is equal to 4 gram of what? A. 4.4 gram of A. So that is what? That is the theoretical what? That is what? The actual heat of what? Of compound what? A. That is what? The actual what? The actual mass of compound A. You can see the actual mass of compound A is 4.4 grams. Question B of number 3 says that what is the what? The name of the type reaction is amplified by reaction 1 and reaction 2. What is the name of the type reaction is amplified by reaction 1 and reaction 2? Look at the reaction 1. I've told you that reaction 1 involves what? The addition of what? Of cyanide, of hydrogen cyanide, the addition of hydrogen what? Cyanide, the addition of hydrogen the addition of what? Hydrogen what? Cyanide. So it's an addition reaction, and the addition of hydrogen cyanide is as a result of what? Sodium cyanide slash what? Hydrochloric what? Acid. When you add what? Sodium and hydrochloric acid together, you use it as a reagent. It will what? It will give us what? Hydrogen cyanide. And hydrogen cyanide, when added to butanol, it will give you what? It will give what? Cyanohydrin. So the type 1 reaction is called, it's known as what? It's known as addition what? Addition reaction. Now they might ask you, if this was cyanohydrin, if you add water to it, it will form what? Carboxylic what? Acid. So when you hydrolyze what? Cyanohydrin in the presence of water, when you add water to it, it will give what? It will give what? Carboxylic acid. It's one of the preparation what? Method used for what? For producing what? Carboxylic acid. Now, here now, the type 2 reaction. The type 2 reaction is what? Is from butanol. You can see butanol is going to what? Butanol is going to what? Butanol. Butanol is going to what? no, it's like a reversible reaction. Like it's like, because normally butanol oxidize to form what? Butanol oxidize to form butanol. Now the case is now what? Butanol forming what? Butanol. So now, so if butanol oxidize to form butanol, now the butanol is being reduced to form butanol here. So that's why there's a reduction taking place here. A reduction reaction in the presence of what? When you reduce what? The reduction of butanol to give what? Butanol. So the reduction in the presence of what? Of lithium tetrahydroaluminate. That's how we call it. Anyway, the presence of what? This is a reducing agent. So the butanol is reduced to butanol. This is the reagent agent LiAlH4 in what? In ether compound known as what? Ethoxyethane. All these things I will teach you in the functional group, how to know ethoxyethane, how to know what ether. If you have not yet known the alpha name of the functional group in organic compound, organic chemistry, go and check my previous video, and later add to the available resources online concerning the functional group of a compound. But now butanol reduce using reducing agents, undergo reduction using the agent of what? Of lithium tetrahydroaluminate 3 in the in ethoxyethane to give what? Butanol. So this is a reduction reaction. So type 2. It just should name it, don't change what. So type 2 is a reduction reaction. So this one is an addition reaction. You add iron to it, and this is what? A reduction reaction. It undergo reduction reaction. Now this reaction, you now say the question about what? State to chemical This reaction now go to what? Dehydration The last one, type 2 reaction here. Undergo this, and finally then this butanol now is being dehydrated. The butanol is dehydrated. Question number 4. Question number 4 before us says that the question number 4 says that state 2 chemical tests used to distinguish between butanol and butanol. The 2 chemical tests used to distinguish between butanol and butanol. State what you will do and what you will see in each cases. Now we have the chemical we are told that we should state the 2 chemical tests. The 2 chemical tests for what? To distinguish what? To distinguish 2 chemical tests to distinguish butanol and butanol. So how do the 2 chemical tests? Now butanol and butanol. What are the tests that we can use to distinguish the 2 The first test is what we call the tolling reagent. The tolling reagent. We are talking about tolling reagent. Tolling reagent is a mixture of it's also known as the ammoniaca of silver nitrate. The ammoniaca is known as the ammoniaca is known as the ammoniaca of silver nitrate. It's called the ammoniaca of the agent is the ammoniaca of silver nitrate. Let me just write that to avoid any more story. Ammoniaca of silver nitrate. What does that mean? You add to produce this tolling agent. The tolling agent is produced by adding the ammonium oxide plus plus silver nitrate. When you mix those 2 together, you have your the tolling reagent. That's how we call it the ammoniaca silver nitrate. So after mixing the 2 together, then you have prepared this is called tolling reagent. So add your tolling reagent to to butana. When you add this toluene reagent, when you add it to what? Butana will form what? Butana, when added, add to what? Add to butana. When you add it to what? When toluene reagent is added to what? Butana, the butana form what? Butana forms what? Butana forms a sliver what? Mirror what? Image. It forms sliver mirror what? It forms sliver what? Mirror. It forms sliver what? Mirror. What do you mean by sliver mirror? It's colorless what? It's colorless what? It's colorless what? State changes to mirror what? Mirror state, such as what? It forms like a mirror, just as it is shown on the what? On the screen. There is kind of mirror what? Mirror screen that you obtain on your test tube. On your test tube from a colorless to a what? To a mirror. We call it sliver what? Mirror. Sliver mirror. It has sliver color and it's formed like a mirror. So sliver mirror. So that shows the presence of butana. So you add what? The toluene reagent, which are made of what? Ammonia gas liver nitrate to butana. While butana gives a positive what? Result, forming what? Forming a sliver mirror. So this is a positive what? Positive test for what? Positive test for butana. Positive test for butana. This test for butana. So now why butanol is negative? Why butan on addition to butanol? Why on addition to what? To butanol? The test is what? Negative. The test is what? Negative. When I say the test is negative, no reactions occur, no physical reaction. The test is negative. On addition to butanol, the test is negative. No physical what? Reaction. Also, when you use what? The second test is what? The use of what? Phthalate solution. Reduction by phthalate what? Solution. Reduction of phthalate solution. Phthalate solution, that is reduction of phthalate what? Reduction of phthalate what? Solution. Now, reduction of phthalate solution. Butana reduce what? Butana reduce what? Phthalate solution. By taking when I talk about phthalate solution, the reduction of phthalate solution by butana also we can use it to distinguish what? We can use it to distinguish from what? From butanol. For instance, now, phthalate solution consists of what? Phthalate solution consists of what? Phthalate. We have phthalate solution A. Solution A and what? B. But it's made up of what? Phthalate solution is made up of what? Copper what? Copper what? It's made up of copper and what? Hydroxyl group. It's made up of what? Copper sulfate. Specifically, it's made of copper sulfate and copper what? Oxide. Hydroxide. It's made up of what? Copper sulfate, copper oxide, and so on and so forth. Majorly now, phthalate solution is made up of copper. Phthalate solution is made up of what? It's made up of copper what? Ion. It's made of copper ion, which make it to be what? To blue in color. Made of copper, which is blue in what? Color. It's a blue colored or liquid. It's a blue colored liquid. So when you add what? When you add phthalate solution plus what? Plus butana. Phthalate solution plus butana. Definitely the blue what? The blue color changes. The blue color changes of solution. When this is phthalate solution plus butana, then the blue color of phthalate solution changes to what? Changes to red or reddish what? Brown. We call it red or reddish what? Brown. Precipitate. That shows the presence of what? Of butana. So this is a confirmatory test of what? Butana. So why butanol show a negative what? Show negative tests. Show is negative to this test. Why butanol is negative to this what? negative to this one test, this test as well. So these are the copper or the Ferlin solution, which is made of copper, changes to reddish what, from blue to reddish what, brown, confirming that what we have to do for now. So that's that about what the test. Question number 5, which is the last question on this what, on this section, is what? Describe the arrangement of bonds around the carbon atoms in ethane and in ethene, and state the bond angle in each compound. Compare the relative bond length of carbon-carbon bond in the two molecules. Now, solution to this question number 5 goes thus. Now, we are given two what? Two compounds here, ethane and what? Ethane and alkene. So this is ethane, and we have what? Ethene. Ethane comes from the family called what? Alkane group. This is an alkane group. And this is what? Alkene what? Alkene group. Ethane is an alkane group. I know. So this one has CN of what? This is CnH2n plus 2. This one is CnH2n. So when you put 2 here, this one will give what? 2 C2, 2 times 2 is what? 4 plus 2 to what? C2, H what? H6. When you put 2 here, because H is 2, 2 here, C2, C2, so I give you C2, H8, C2, H8, C2 what? H4 rather. C2, 2 times 2 is what? 4. So C2, H4. Now, because ethane now has what? It's a saturated hydrocarbon, that it has what? Carbon-carbon single bond. So every bond in what? In ethane is what? Is saturated. So we have C. Then with how many hydrogen now? 1, 2, 3. So we feed this one, making it 4. 1, 2, 3. This one is also having 4 bonds. So we have hydrogen, and hydrogen. So now that's complete. Now you have C, double bond C, then we have what? This unsaturated hydrocarbon, we have CH. Yeah, this one is also CH. So that is what this is. This is the two compound that we are now to talk about. Now, decided to describe what? The bond around the carbon atoms. Now, the bond around this carbon atom, we call it what? The bond is sp3 what? Bond. It's a single bond. These are what it's called as well. It's a single bond that is sigma what? They are sigma bond. This bond is sigma bond. And it's called sp3 what? Bond. So we should describe what? The bond is what? It's an unsaturated bond known as what? Sigma, and the saturated what? Saturated bond. This one has saturated bond. Ethane has saturated bond called what? Sigma what? Called sigma bond. As a result of what? As a result of sp3 what? Hybridization. sp3 hybridization. Hybridization is the process by which orbitals of carbon combine with one another to form hybrid orbitals. So sp3 what? Hybridization. And because of this sp3 hybridization, we have tetrahedral what? Shape. This carbon here, this has a shape, a tetrahedral shape. So all the thing has a tetrahedral shape, almost very what? Tetrahedral shape. They have tetrahedral because of what? Of the what? Of the sp3 what? Hybridization. So the angle, the bond angle between this one, the bond angle here is 109.5 degrees, and it's 109.28 minutes. So that's that. So now for this for ethane now. So for ethane, and the last thing they say you do, describe what? The bond length. The bond length here will be what? The bond length of this, the bond length of ethane C2H6 will be what? Longer. It's longer as a result of what? Because it is only, we are only having what? Single bond throughout. This single bond, there is no any force of attraction that would do what? They have come together. We only have single bond here. So, and the lesser the what? The S character the what? The longer the what? The bond what? The bond length. The lesser the s character, that is the s orbital. The what? The percentage of what? Of s orbital here is, when you calculate it, it is 25%. Compared, we add 1 plus 3, it is going to be 1, it's going to be 4. So 1 over 4 times what? 100 to give you 25%. So the lesser the s, the lesser the what? The s orbital, the longer the length, the bond length of what? Of a compound, that is an alkane group. So the bond length of what? Of ethane is longer than that of what? Than what? C2H2, which is 18, because 18 has what? Pi bond, as a result of increase in what? In participation of what? Of p orbital. So now we are going to be treating that in our subsequent class. So do well to press the subscribe button and the green button in order to get all these technologies that I'm fixing. So now this is about what? About what? Ethane now. Now ethane here is, ethane here is unsaturated what? Saturated bond. So saturated, that's the unsaturated bond, that's the C double bond. You have C double bond, C double bond, C double bond. Now this one, the first one, C, that's unsaturated bond, C double what? Bond. The first one here is pi bond, this one is sigma bond. It's a result of what? This pi, and this one is what? This one is sigma. And if you want to draw it out, this is how to draw the actual thing out, is like this. They form a trigonal. This is the bond with this one, and they form a trigonal. So it means that the bond here is trigonal. The bond here is what? The bond here is the bond angle is 109.5. This one is trigonal, that is 120 degrees. This is trigonal. Trigonal, yes, trigonal, this is 120 degrees. So, and the bond here is a result of pi and what? And sigma bond. The pi and sigma bond. And this unsaturated is as a result of what? The unsaturated bond is as a result of what? Is as a result of pi bond. And this makes the bond length even more shorter, which makes the bond length of the compound shorter. Because it makes the bond length shorter, because it reduces the participation of what? Of S character. Now, the hybridization, which is as a result of what? Which is as a result of pi bond, which makes the bond length shorter. The pi bond now, it has what? It has sp2 hybridization. It also has what? It also has what? sp2 what? Hybridization. Meaning that what? There is an increased participation of what? Of s orbital here. So, and because there is an increased participation, although this pi bond is there that make it shorter, and is the percentage of what? S here is increased, so to say. So now we are now asked to calculate what? Compare each of the bond lengths of the what? So this one, the bond length here is shorter. Please know that shorter what? Which made the bond length of what? Shorter. This one is what? Longer. So now in terms of bond length, the thing in terms of bond length now, the bond length of 18 is what? 18C is greater than what? So, but and also what are we asked to state? So the carbon, this one is trigonal, this one is tetrahedron. Please note that this one is tetrahedron. So this is tetrahedron, or we call it tetrahedra. This one is trigonal. The bond is trigonal. This one is what? Tetrahedra. This one is what? Trigonal. This one, the bond length is what? Is longer. The bond length is shorter. The what? This one has sp3 hybridization. This one has what? sp2 what? Hybridization. So these are the difference between the what? the ethane and the ethene and the arrangement of carbon in the molecules, and also as well as what the bond length. We have come to the end of today's class. Please, if this video has helped you, please press the notification button and like button in order to be able to serve more people better. Please and please, we beg you to also share these videos and keep on watching the Leaders Online Academic tutorial. Thanks and God bless you.